And welcome back to another video. We are here with the next paper in the 2018 SATs for maths. This is the first reasoning paper. I want to dive straight in. So let's take a look. Here we go. Paper 2 reasoning. Now in these questions, very different to arithmetic because you are given, instead of just some maths to do, you're given it in the context of a word problem quite often. You might need to draw lines, you might need to draw circles, lots going on. So let's dive straight into question 1. Here is a shape on a grid. Complete the design so that it is symmetrical about the mirror line. Use a ruler. This is where you're going to be way better than me, okay? Because I do not have a ruler tool. So you'd be having a ruler in real life, and this is the important thing. You're counting away from the mirror line. So let's go to our shape. We count 1, 2, 3 squares wide. So we go 1, 2, 3 squares wide here. I'm then going to count back, but that can get confusing. So always start from the mirror, from the symmetry line. 1, 2 squares wide. So I'm going to go here 1, 2 squares wide. That's my outside of my shape. Then again, start in the middle. 1, 2 squares wide. We're going 2 squares wide again. See how I'm tracing the outline in dots? That's just how I like to do it. You guys might also want to draw it as you go. So we can see here, this line comes back in towards the symmetry line. So we have to come in back towards the symmetry line. Then we can go down. I'm always tracing the same. This is when it comes interesting down here. Here's my mirror line and my shape is actually 1 away. So here's where my shape would be. And you can see here how this line goes away from the symmetry line. We need to go away from the symmetry line in the opposite direction. And then that line carries on down another square's width. Okay, so now we're here, match here with here, and you'll see it's just a straight line down. So hopefully at that point, your brain starts to click. These are symmetrical. You'll be using a ruler, but the number one bit of advice, guys, is to count from the symmetry line. Let's keep going. Question 2. Stefan completes this calculation. 95 subtract 67 is 28. Write an addition he could use to check his answer. This is all about using the inverse. So to check an answer, if we have just subtracted, we can take the answer, 28. So let's put that straight in here. And we have an option. We could add on what we subtracted. That's one of the ways we could do it. Or we could put 67 first and then add on the answer. It doesn't matter which way around we do it. The important thing is that we have this number here, let's call this number A, and this number here, let's call this number B. To check our answer through addition, we'd have to add these two up. We can't add up using the 95, that would be incorrect. So let's take 67, we're gonna add that back on. And then if he's correct, we should end up with what we started with at the top, which was 95. So this is about seeing if you know what the inverse is. Can you do the opposite of what just happened to check an answer? But it's in a reasoning question, so it's not how you might expect to see it. Question 3, on the line below, mark the point that is 6.7 centimeters from A. Now, guys, again, I don't have a ruler tool, but this is something really important. I'm going to show you on the screen now. Your ruler roughly, although not exactly because I can't draw a straight line and we know rulers are famously straight lines. Your ruler looks like this. This is not 0. This is not where we measure from. If you look at your ruler really carefully, it starts off with the line that says 0. So all I want to say to you is you must match up this A with 0, not with the end of your ruler, exactly with where it says 0. Then you can measure until it gets to 6 centimeters, and you'll notice it goes to 7. This one's 6.7, so you've got to count millimeters as well. 1, 2, 3, 4, 5, might be a longer line, 6, 7. So you're going to make sure it is exactly correct by lining up the 0, counting to exactly 6.7 with 7 millimeters, and you're going to mark it on your answer sheet. Mine, we just have to do a best guess. Question 4. These diagrams show 3 equivalent fractions. You know they're equivalent because look, the rectangles on the outside are all the same shape and the shading is taking up the same amount of area. You can see here 3/4. 3 are shaded out of 4 parts in total. The next one is 9 are shaded. How many parts are there in total in this shape? There are 12. This is a simple counting question. And then 24 parts here. How many of those are shaded? 6 in each row, 12, 18. So even if you weren't too confident there on equivalent fractions and converting them, you can use the pictures to help you. This is the good thing about the reasoning paper. It is tricky, but it gives you prompts and guides as well and hints. Question 5. Here are the temperatures in 4 cities at midnight and midday. So you can see all the information there. Paris, Oslo, Rome, and Warsaw at midnight and midday. quite a difference there in some of them. Let's look at the question. At midnight, how many degrees colder was Paris than Rome? So let's go to midnight. This is Paris, -4, and Rome was 3. Classic question here, guys, of finding the difference between a positive number 3 and a negative number -4. Something that we must remember when we're doing this is that it goes through 0. That's vital. The answer is not 1, because some people see 4 and 3 and just think 1 is the difference. No. There's a jump of 3 past 0 to go to +3. There is a jump of 4 past 0 to go to -3. So the total jump is 4 and 3 together. That's going to give us 7 degrees. Next question. Which city was 6 degrees colder at midnight than at midday? So we're looking for which city had a difference of 6 degrees. Again, it's trying to trick you here. 4 and 2 make 6, but no, this is -4 and -2. There's only a jump of 2 there to find the difference. Next one is -13 to -7. Now imagine that in a number line, we're at -13. How many jumps to get to -7? Well, we're not going past 0 in this one. So it's going to be 1 to 12, 2 to 11, 3 to 10, 4 jumps to 9, 5 jumps to 8. You see where this is going? 6 jumps to -7. So there is a 6 degree difference there in Oslo. So the answer to this question is Oslo. Next one. Question 6. We are doing well here. These numbers in a sequence decrease by the same amount each time. What would be the next number in the sequence? So let's take a look at what's changing. I can see straight away the 604 never changes. So it's nothing in the hundreds or tens or ones. I do notice, however, this digit here, the thousands digit has gone 3, 2, 1, 0. Now think of it like this. What's 1 less than 0 is -1, and we know that's nonsense. So I want you to think about it like this. 303 thousands, 302 thousands, 301 thousands, 300 thousands. What's the next number? 302, 301, 300. We can look at it like this. It becomes easy. It's 299 thousands, and then 604 is still untouched, unchanged. Question 7, tick the 2 numbers that are equivalent to 1/4. We just have to know these facts. It really is as simple as that. 0.25 is equivalent to 1/4. Because we know 0.25 is equivalent to 1/4, we also know that that is the equivalent to 25 hundredths if we're really competent with our fractions, decimals, and percentages. So we can tick this box as well. This is 3/4, nonsense. This is a half. This is nothing. 2/5, that's just 0.4. Doesn't make any sense to this question whatsoever. Next question, question 8. Ken buys 3 large boxes and 2 small boxes of chocolate. Each large box has 48. Each small box has 24. How many chocolates did Ken buy altogether? Let's start with the large boxes. He bought 3 of them. So there's 48, and you must show your working when you see this. Show your method. Trust me, it's worth it. 48, and he bought 3 of those boxes. I'm going to actually set up the other one as well, because he bought 2 small boxes with 24. Now, what's really interesting is you might be able to do 24 times 2 in your head. I would still just write it out in this question to make sure. I'm going to start with 24 times 2 because it's quite simple. That's 48. Now you might notice, actually, it's another lot of 48. So we could do 48 times 4. I'm just going to do this to make sure I get it right. It's up to you if you're more confident with those shortcuts. 8 multiplied by 3 is 24. And then 3 multiplied by 4 is 12. Plus the 2 is 144. Then we just got to combine them. 144 plus 48 is 192 chocolates in total. Again, just write it out. It says show your method. Just do it. You'll have time likely in this test. The timer isn't too tight. You can just add them up there. Next question, question 9. The list below shows the years in which the Cricket World Cup was held since 1992. 92, 96, 99, 2003, 2007, 2011, 2015. Adam says the Cricket World Cup has been held every 4 years since 1992. Adam is not correct. Explain how you know. We're going to have to explain it in words down here, but let's start off by actually looking at the maths. Every 4 years, 92 to 96 is plus 4. He's right so far. 96 to 99, straight away there's a problem. If it was every 4 years, it should be 2000. This is plus 3. So down here in words, what you'd have to do is explain how going from 1996 to 1999 is not 4 years. It is not 4 years. It is 3 years. Now, I'm writing this rushed, scruffy. you get the gist. You'd have to write that in a sentence. 1996 to 1999 is not 4 years, it is 3 years. It's about providing proof for what he said being wrong. Next question. Question 10. Write the correct symbol into each box to make the statements correct. Just work out both sides. Greater than, less than, or equal to. So let's take a look here. 11 times 12 is 132. 15 times 10 is 150. Therefore, this is larger. It's just being systematic, guys, one step at a time. 90 divided by 30 is 3. 60 divided by 20 is 3. They are equal. 120 divided by 4 is 30. 160 divided by 8 is 20. 30 is larger than 20. 30 multiplied by 8 is going to give us 240. 100 times 10, that's huge. It's obviously 1,000, so clearly that is much bigger. So that's how we answer this question. Just write it down. Look how much writing down I'm doing. I'm a maths teacher. Okay, I can do this in my head, but I just write it down to make sure I get this correct. Question 11. Here is a drawing of a 3D shape. Complete the table. Number of faces. Now let's think about this. There's one face at the top, one face at the bottom. Now how many are there going around? One at the back, 2 at the sides, and 1 at the front. That is 6 faces in total. It's all about spatial reasoning this and being able to visualize something. This is almost like, think of it like a cube, but the top square face has just been shrunk in. It would still have 6 faces. Number of vertices. They are where the edges meet. 1, 2, I'm going to do it in bigger circles. 3, 4 at the top. And look, we're also going to have 4 for the base, aren't we? Because it's still a square on the base. So 4 plus 4 is 8. Number of edges, quite straightforward. 1, 2, 3, 4. 1, 2, 3, 4 at the bottom, so that's 8 so far, but don't forget the edges in the middle holding up. 9, 10, 11, 12. Funnily enough, these numbers are the same that you would get for a cube, because this is very similar to a cube, this shape, just as I said, the top face has been squished to make it slightly smaller. Question 12, here is a shape on a grid. You can't see it just yet. There it is, there's the shape. Let's see what we've got to do. The shape is translated, that means moved. So that point A moves to 7, 8. Let's look for 7, 8. 7 across, 8 up. So this is point A now. That's the new point A. I'm going to call it A1. That is the new point A. So if that's the new point A, what we need to do is draw the rest of the shape in the new position. So think, from point A, we go left 2. So in our new point A, we go left 2. Now we're here. What do we do when we get here? We go 1, 2, 3, 4, 5 down. So let's do that too. 1, 2, 3, 4, 5 down. Cool. Now we're down here. What do we do next? We go across 1, up 2. Across 1, up 2. That gets us right here. Then we could draw a line to match that up. Once we're here, we go across 1, down 2, which gets us down to there. We're just copying this shape. Oops, that is way too much of a line. And we need to make sure you'd have a rubber. You could rub that out down to here. And then we just join it back up. So when we translate a shape, guys, the shape stays exactly the same. It just moves its position. We matched up the A's and we just went round just like that. Okay, question 13. Circle the improper fraction that is equivalent to 6 7/8. So what we need to think about here, we're looking for eighths. There are 8 eighths in one whole. Okay, 8 eighths is one whole. So how many eighths are there in 6 wholes? 6 lots of 8. So we do 6 times 8 and we get 48. So 6 is 48 eighths plus the 7 we already had. So 48 plus 7, that's going to get us to 55. And that is 55 eighths as our answer. We cross our fingers and we hope it's there. Of course it is. So we circle that. And we move on. Question 14. Write these fractions in order, starting with the smallest. Now, the first thing I'll say is you can see straight away that 6/5 is the biggest. How do we know this? It is the only improper fraction. This is bigger than one whole. The numerator is bigger than the denominator. It's the only time it happens. So this must be the largest one. Now, once we've got rid of that, we can actually look at these. Now, normally we want the denominator to be the same to compare fractions. However, when the numerators are the same, we can also compare them in a similar way. We've got 3 of whatever these are and 3 of whatever these are. So now the question becomes, are fifths bigger or smaller than quarters? And we know fifths are smaller. If you have a whole pie here and a whole pie here, 1/5 of this pie would be split into 5 equal pieces. whereas 1/4 would be split into 4. The more pieces we split something into, the smaller the pieces will be. So 3/5 is smaller, it must be, than 3/4, because fifths are smaller than quarters. We didn't have to do any converting there. We could have spent a lot of time changing all the denominators into 20ths and then done it, but just using our understanding of fractions, really good reasoning question there. Question 15, a box contains a tray of melons. How wonderful. There are 15 melons in a tray. So there's 15 in each of these tray. I'm just going to draw it on. I like to draw things on the pictures. They help me. There are 3 trays in a box. We can see that. The supermarket sells 40 of these boxes. My goodness me. How many melons does the supermarket sell? Well, firstly, we need to work out how many melons are in a box. So let's show our working out. There's 15 in a tray. And there's how many trays in a box? Let's make sure. 3 trays. So 15 multiplied by 3, that gets us 45. So there are 45 melons in each tray, and in each box. Let's get that right. And we sold 40 boxes. So we've got 45 multiplied by 40. Again, like I spoke about in the other video, I can split 40 into times by 4 times by 10, because 4 times 10 is the same as 40. I've got a factor pair. That's a fair swap. 45 times 4. That's going to get me to 180. But I've still got to multiply by that 10. And I get 1,800 melons. Wow, that must have been a good day for the shop. Must have been a hot day. Needed some refreshing fruit. Next question, question 16. Adam wants to use a mental method to calculate 182 subtract 97. He starts from 182. Here are some methods that Adam could use. Tick one that is correct. So we want a method that is the same as take away 97. Let's take a look. Add 3, then subtract 90. So we start here. If we add 3 and then subtract 90, that is not going to get us back 97. That is wrong. I'm going to ignore that one. I'm going to cross it out. I don't like it. Subtract 100, then add 3. Aha. If I subtract 100, so I'm 100 less, but I add 3 back on, I'm actually at 97 less. This is a perfectly good method. So this is testing your skills on quick methods. It says here, tick the methods multiple, plural. So I'm going to keep going. Add 7 and then subtract 90. Let's think about that. Add 7 and then subtract 90. Well, if I'm here, if I add 7 and then subtract 90, that is the same as subtracting 83. And that is not subtracting 97. That's nonsense. I'm not taking away enough. If I'm going to add something, I need to subtract it. But here's the really important thing, which is hopefully going to highlight something that's really important for you. I read it wrong. This is such an easy thing to do. It says subtract, then subtract. Why did I write plus? Guys, I'm not even going to pretend. That was a genuine mistake I made, because I was worried then thinking, where's the other one? It is this one. Of course, if you're subtracting 97, you can do it in parts. Take away the 7 and take away the 90. As long as you take away the whole thing, that works. What a brilliant, showing you guys there how even a teacher can make a mistake in these tests. They are tricky. Watch what you're doing. Check your answers. And look, by me writing this down and jotting it down, I noticed actually I need to check this again. It was wrong. So always be hyper vigilant. Yeah, so that is a good method. Subtract 3, then subtract 100. That is just subtracting 103. I hate it. I don't like it. So they're the 2 options he could use. I nearly only found 1. Question 17. There are 28 pupils in a class. The teacher has 8 litres of orange juice. She pours 225 millilitres for every pupil. How much orange juice is left over? Wow, what a question. We need to do 225 and we're going to multiply it by 28. So we can do that to find out how many milliliters she poured. This is going to be long multiplication now. So 28 pupils, 225 each. Let's do it. This line is going to be times 20. This line is going to be multiplied by 8. 8 times 5 is 40. 8 times 2 is 16, plus the 4 is going to give us 20. And then 8 times 2 is 16 again, plus the 2 is 18. So we've got 1800 there. Now to times 20, put a placeholder in. Now we can just times by 2. 2 times 5 is 10. 2 times 2 is 4, plus the 1 is 5. 2 times 2 is 4. So let's add this up and find the total amount of juice that the teacher gave out. 8 plus 5 is 13. We have 6,300 milliliters. Now let's see how many she had to start with. 8 liters. Here's a problem. Different units. Just change this into 8,000 mil. Once we've got 8,000 mil, we can subtract 6,300. You guys could do you could do the column method and do some exchanging there. 8,000 take away 6,300, you should end up with 1,700. But remember your units. It's in milliliters. Really important because we had liters and milliliters in the question. You had to change it to be milliliters, and that is correct. Question 18. Last year, Jacob went to 4 concerts. Lucky boy. 3 of his tickets cost £5 each. The other ticket cost £7. What was the mean cost of the tickets? Now, mean means average. We've done a whole video on this. You can check it out on our channel. But this is just basically testing. Do you know what this vocabulary means? It means the average. So we had 5, 5, 5, and 7. If we add these up, what do we get? We end up with £22. And this is what it's also testing is your decimal, because we need to divide 22 by 4. So put it into a bus stop method. 22 divided by 4. You can probably tell straight away it's not going to go in exactly. 0 4s in 2, exchange over. How many 4s in 22? Well, there are 5 4s in 22 with 2 left over. So you need to put in your decimal place now. So we're going to expand this, put in the decimal at the top and the bottom, and a placeholder with 2 there. 4s into 20 is 5. £5.5. Well, we know, don't we, that for money, we need 2 decimal places. The mean cost of one of his tickets was £5.50. You can check this. If you multiply £5.50 by 4, you should end up back at 22. So if you wanted to check it, you can. Question 19. Layla wants to estimate the answer to this calculation. 3 9/10 take away 2 1/8 plus 1 4/5. Tick the calculation below, just 1. It says here, tick 1. That is best estimate. Now, what are we really close to here? 3 9/10. That is really close to a whole. So it's 3 plus 1. So I'm going to treat this as 4. Subtract 2 1/8. 1/8 is really close to just being 2. So it's only 1/8 extra. So I'm going to treat this as 2. And then here, 1 4/5. Again, 4/5, a high fraction there, close to 1 whole. So I'm going to treat that as a whole, and I'm going to treat it as plus 2. So a good estimation here would be 4, subtract 2 plus 2. And we can tick that there. It's just basically the whole number that we're closest to. Question 20. The length of an alligator can be estimated by measuring the distance from its eyes to its nose and then multiplying that distance by 12. What is the difference in the estimated lengths of these 2 alligators? There's a few ways to do this. You can do 17.5 times 12 and get an answer, and 15 times 12 and then finding the difference between them. Or you can be very sneaky. You can find the difference first. So 17.5 take away 15. Put in the 0.0 as a placeholder just so you don't mess up. 5 there with decimal place. 7 take away 5 is 2. 1's cancel out. So the difference is 2.5 centimeters. Now you can just multiply the difference by 12 to get the distance. So we're going to do 12 multiplied by 2.5. Firstly, let's partition 2.5. So we'll do 12 times 2. That will get us to 24. And then we can do 12 times 0.5. Remember our trick from the arithmetic test, guys. We can say the multiplication, firstly, we can say is like an of, and we can do 0.5 as half. So what we're really doing when we do 12 times 0.5 is finding half of 12, which gives us 6. So we have 24 is 2 lots of 12. 6 is half lot of 12. Put them together, and you get 30 centimeters as the answer. A nice little trick there to save time. Find the difference first before you go multiplying. Question 21. Amina is making designs with 2 different shapes. She gives each shape a value. Total value is 147. Total value is 111. Calculate the value of each shape. Now this is like algebra. Okay, so we know the hexagon has a value. We don't know what it is yet, but we know it has a value. And we know that this kind of slice shape, this cone shape, has a value. Now, if this is 147 and this is 111, the first thing you should ask yourself is, okay, what's the difference and what's the same? You'll notice here that we have 1, 2, 3 of these cone shapes. And that is cancelled out over here. 1, 2, 3 of the cone shapes. What we've also got here is a hexagon. And that cancels out with this hexagon. So the only thing different about these 2 shapes is this hexagon here. Now, what does that mean? Why is that important? Well, if there's only one thing different, then we know the difference between 147 and 111 is the value of one of the hexagons. So 147 take away 111. This is 6, 3, and then 0. They just cancel out. So I know this hexagon is worth 36. So the hexagon is worth 36. What's the cone shape worth then? Quite simple, really. Let's go back to this one. Let's take away the value of the hexagon. So 111, take away the hexagon, take away 36. What are we left with here? So we've got 0 there and exchange over. 11 take away 6 is 5. We have to exchange again. 10 take away 3 is 7. So we're left with 75. That means that 3 cone shapes is worth 75. So you guessed it, we have to divide 75 by 3 to give us the value of 1 cone shape, and we end up with 25. So the cone shape is 25, the hexagon is 36. All about asking yourself what is the same and what's different, and using these values here, 147, 111. The only thing that changed from 111 is we added a hexagon. So we just needed to find the difference. We can copy it in here. We have 36 for the hexagon. We have 25 for the cone shape. I love that question, a really good reasoning question. This is the net of a cube. What is the volume of the cube? What a brilliant question. So to find the volume of a cube, if I draw a cube out here, and it's going to be 3D, like we've already folded the net. To find the volume of a cube, we need to know the height multiplied by the width multiplied by the depth. Now, the cool thing about a cube is it's always going to be the same number because cubes are made up of squares. So let's take a think. I need to work out what one of these edges, or these sides rather, what's the length of one of these sides? Well, I know this whole length here, from here to here is 20. How many sides of a square fit in? 1, 2, 3, 4. So let's do 20 divided by 4. That gives me 5. I know now that each side of my cube is 5. So imagine I took this net and I folded it into this one. I would have 5 times 5 times 5. What is 5 cubed? 5 times 5 is 25. You could write it out like this. And it's again, just like we talked about earlier, multiplying 3 numbers. 5 times 5 is 25. So I can just cross them out there. Times 5 is 125 centimeters cubed. All about knowing your maths, guys, how to find volume. If you didn't know how to find volume, you'd be really stuck on this. Even if you did, you then had to use your problem solving skills to work out the side of one of the length of one of the sides. Question 23. The length of a day on Earth is 24 hours. The length of a day on Mercury is 58 2/3 times the length of a day on Earth. What is the length of a day on Mercury in hours? Well, firstly, let's do 58 times 24 and see what we get. So again, long multiplication. 4 8s are 32. 4 5s are 20 plus the 3 is 23. Put a placeholder in. 2 8s are 16. 2 times 5 is 10 plus the 1 is 1,160 in total there. So once we've got 1,160, what I want to see is the total. So 2, 9, 3, 1. But we've done 58 times. Now we need to do 2/3 times. So we think again, 2/3 times 24. Well, we know, don't we, that that times means of. What's 2/3 of 24? 1/3 would be 8. So 2/3 is going to be 16. Then all you have to do is do 1392, which is 58 times, plus 16, which is 2/3 times, and write the total in here. So we've got 1,408 hours. Tricky question, lots to do, lots of working out. But if we just partition what we're timesing by and then add it up at the end, we're going to get the right answer. And that is the end of paper 2, which is your first reasoning paper. And guess what? Of course, we'll be here with the next one. So you've done arithmetic. Now we've done paper 1 reasoning. We're going to finish it off with the last reasoning paper, and I will see you then.